Good morning. I am Devisena. In this lecture, we are going to discuss about traditional TCP congestion control. This topic is present in the subject wireless networks. Traditional TCP. The transmission control protocol, that is TCP, is one of the core protocols of the Internet Protocol suite, often simply referred to as TCP/IP. TCP is reliable, guarantees in-order delivery of data, and incorporates congestion control and flow control. TCP supports many of the Internet's most popular application protocols and the resulting applications, including World Wide Web, that is WWW, email, file transfer protocol, that is FTP, and secure shell. The major responsibilities of TCP in an active session are: it provides reliable in-order transport of data, that is to not allow losses of data; control congestions in the network, to not allow degradation of the network performance; control of packet flow between the transmitter and the receiver, to not exceed the receiver's capacity. TCP uses number of mechanisms to achieve high performance and avoid congestion collapse, where network performance can fall by several orders of magnitude. These mechanisms control the rate of data entering the network, keeping the data flow below a rate that would trigger collapse. There are several mechanisms of TCP that influence the efficiency of TCP in a mobile environment. Acknowledgements for data sent or lack of acknowledgements are used by senders to implicitly interpret network conditions between TCP sender and receiver. A transport layer protocol such as TCP has been designed for fixed networks with fixed end systems. Data transmission takes place using network adapters, fiber optics, copper wires, special hardware for routers, etc. Let us see a small analogy for this congestion control representation. Here is a diagram. Here we are having so many cars. Because of that, traffic occurs and it is not possible for a car to flow properly. How this scenario can be changed? Congestion control can be easily overcome with the help of the traffic signals. With the help of these traffic signals, the movement of vehicles can easily be handled properly. And also, if the vehicles use the proper lanes means, then the movement of the vehicles is also easily handled. This is indicated in this diagram. Let us see the concept of congestion. Here is a representation of packets delivered and how many packets reach the destination. The packets that are sent by the sender completely reaches the destination means there is no loss of data packets. But for example, if 100 packets are transmitted by the sender, then appropriately 90 or 95 packets reaches the destination means it is somewhat manageable. But if 50 packets dropped and only 50 packets reaches the destination means it may be a worse scenario. This is indicated in this diagram. Congestion may appear from time to time even in carefully designed networks. The packet buffers of a router are filled and the router cannot forward the packets fast enough because the sum of the input rates of packets destined for one output link is higher than the capacity of the output link. The only thing a router can do in this situation is to drop packets. Here is a representation of the buffer which comprises of the data packets reaches the router. If so many buffers reaches the router at a time means because of that congestion takes place in the internet. This is indicated in this diagram. Another representation of drops of overflow packets. So many sources sends the data in the form of packets to the routers. Because of that, the congestion takes place in the router. Due to the congestion, the router is overflowed and there is a possibility of drop of packets in the router and only very few packets reaches the destination. This is indicated in this diagram. Traditional TCP congested router representation is shown below. Here, sender sends the data packets to the router. Due to the overflow of the data packets, the router becomes congested. Because of the congestion, some packets may be dropped out, that is indicated, and remaining packets only reach the receiver. And as soon as the receiver receives the data packets, it indicates the sender through the acknowledgements. This highlighted packet indicates that this packet is missed by the receiver. This is represented in the diagram. A dropped packet is lost for the transmission and the receiver notices a gap in packet stream. Now the receiver does not directly tell the sender which packet is missing but continues to acknowledge all in sequence packets up to the missing one. The sender notices the missing acknowledgement for the lost packet and assumes a packet loss due to congestion. To mitigate congestion, TCP slows down the transmission rate dramatically. All other TCP connections experiencing the same congestion do exactly the same, so the congestion is soon resolved. Now we see traditional TCP slow start. TCP's reaction to a missing acknowledgement is quite drastic, but it is necessary to get rid of congestion quickly. The behavior TCP shows after the detection of congestion is called slow start. The sender always calculate a congestion window for a receiver. The start size of the congestion window is one segment, that is TCP packet. The sender sends one packet and waits for acknowledgement. If this acknowledgement arrives, the sender increases the congestion window by 1. Slow start representation is shown below. Here is a representation. The sender initially sends one data packet to the receiver. As soon as the receiver receives the data, it sends acknowledgement to the sender. Now the sender increases the congestion window by 2. As soon as these two data packets reaches the receiver sends two acknowledgements to the sender. Now the sender increases the congestion window by 4. So 4 data packets is being sent by the sender to the receiver. All the 4 data packets reaches the receiver, then receiver sends 4 acknowledgements to the sender. This is indicated in this diagram. But doubling the congestion window is too dangerous. The exponential growth stops at the congestion threshold. As soon as the congestion window reaches the congestion threshold, further increase of the transmission rate is only linear by adding 1 to the congestion window each time the acknowledgement come back. Now we see the congestion avoidance technique. Congestion can occur when data arrives on a big pipe, that is a fast LAN, and it gets sent on a smaller pipe, a slower WAN. Congestion can also occur when multiple input streams arrive at a router whose output capacity is less than the sum of inputs. Congestion avoidance is a way to deal with lost packets. The assumption of the algorithm is that packet loss caused by damage is very small, that is much less than 1%. Therefore, the loss of packet signals congestions somewhere in the network between source and destination. There are two indications of packet loss: a timeout occurring and the receipt of duplicate acknowledgements. Congestion avoidance and slow start are independent algorithms with different objectives. But when congestion occurs, TCP must slow down its transmission rate of packets into the network and then invoke slow start to get things going again. Congestion avoidance and slow start require that two variables be maintained for each connection: a congestion window CWND and a slow start threshold size SSTHRESH. There is another representation for congestion avoidance. In this graph, slow start is indicated, congestion avoidance, congestion point of network, threshold set is also indicated. The graph is between congestion window and round trip transmission, that is RTT. Traditional TCP congestion control slow start congestion avoidance phase representation is shown below. Here is a representation. Initially, slow start phase, that is exponential growth, occurs in slow start phase. Packet loss occurs, that is detected, and due to that packet loss, congestion avoidance phase takes place. That is, during the congestion avoidance phase, linear growth occurs. This is indicated in the diagram. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video, means you can share this video to your friends.